So welcome to computer lecture number 6, and this computer lecture will introduce some basic SAS analysis, and this is very basic. So the idea is to show you what SAS looks like and then do just a few instructions. And so there's a lot to learn in SAS, and it's also like R. It's quite a popular computer package for statisticians. The name SAS, initially it was known as Statistical Analysis System, but only the abbreviation these days are used because SAS is not only a statistical analysis package. You can do a whole lot more with SAS. So it's quite popular in business as well as among academics. So learning SAS it's a useful investment. So that's what we will look at. Just a quick introduction. And the way that we're going to look at it is by asking ourselves, how can I import a data set? In our case, we're looking at the multivariate data. And how can we do some analysis on the multivariate data sets that we have seen so far? Okay. So again, we're going to look at the bound data, and then we're going to do some coding in SAS. We're going to print the data, do a normality test. That's what we've done before. Calculate the mean vectors. We can do a t-test like we've seen before. We can calculate the correlation matrix, do a regression, and then based on the regression output we can do a normality test in SAS. So everything that you did in R you can also do in SAS. The two packages differ a lot, but you can more or less generate the same output from the two packages. So let's go to SAS, and what I did is I prepared again a script. So this is just a text file, and this is again to make things easier to copy and paste, and I'm going to use this to illustrate the SAS package. Okay, so SAS, what does it look like? So this is the icon, what it looks like, and then if you open SAS, this is what the package will give you. Okay, so there's a few things to be aware of. You will notice as we analyze or generate output, it will pile up over here under results, and then there's some more things that you can change over here, but for the moment we're just going to stick to some basic analysis. Notice there's an editor window over here where we will actually type in our code. So similar to what we saw in R, there was a console. This is similar to the console in R where you type your code, and then once you've typed your code, you would run it. You'll see there's a submit button where you run your code. Other windows, you will see there's an output window, but later when we do the analysis, you'll find that SAS generates a fourth window over here with the output. What's nice about SAS is it creates this log window over here, and the log window is quite helpful in finding mistakes in your code. And it's when you work with SAS, you will find it's different than R, and then find your mistakes that you will make over here in SAS will be different compared to your mistakes in R. But let's do a few short analysis in SAS. Now, like I said, there's lots more that I can explain about the SAS environment over here. But basically what we want to do is, once we've imported our data, we want to analyze the data, get to the results, and interpret it. And later when we're done, we want to save all our code and our results. Okay, so let's see how we can go ahead with the SAS analysis. Okay, so let's go to the editor window, and the first thing that we want to do is to import the data. Now we're going to use the bone data first, and if you look at the following, notice over here I use a / star and then a star and a /. Now the reason for what I'm doing over here is to show you first how you can make comments in your code. So whenever you want to comment, if I take this away over here, you will find something else is happening. The color changes, but as soon as I put a star, or you can even put it without the /. I just like to use this because it gives some structure, or it is some neat layout to my code or commands, and this is what we use to make comments. Okay, so importing the data. So again, I like to put titles in SAS. It's something that may not be as easily done in R, but the reason why I use the titles in SAS is because you will find you can just add and add on as much as analysis as you want to this file over here. And then eventually you want to distinguish between your output. You want to know, what did I do in this portion of the output? And that's why the title is important. So using the title is just important to identify what have I done at certain sections of the analysis. The semicolon, this is an important symbol in SAS. Notice after every command there's a semicolon. And this is what we call a data step. So R language, they talk about step. And so I'll use the word step quite a lot. So the data step, it's just a way to import the data. Now there's multiple ways of importing the data. And for the moment, what we're going to do is we're just going to use the data lines over here where we specify the values. So data, we're going to call it bone. And an input is just a way to give labels or names to the variables. And so what we're going to do is we're going to copy the bone data. So let's go to the bone data. So here I'm going to copy everything. Okay, so copy this and then go back to SAS, and I'm going to paste it over there. Okay, so SAS has these nice colors that we can see over here. And usually if you copy the labels, you can just cut them, and then I put them over here as my input. Okay, so now I have the names as well. Notice there's a tab between this. Now SAS doesn't have a problem with the tab or a space. So if you copy it and paste it, normally you have this tab over here between the numbers, but SAS is okay with it. So the first column are the individuals. This is Y1, Y2, Y3, and Y4. And at the end, I must just remember to put my semicolon. So data lines specifies that the data is following, and then this is the end of the data. Okay. So the next thing that we want to do is we want to print the data just to see if we imported it correctly. Okay, so that's always a step that I do. And again, I put some comments over here to remind me what I did. So we have the print step, and then I have to specify what do I want to print. I want to print the bone data, and then I can specify the title 2, which will just comes below this first title. What do I want to print? I want to print variable 1, y1 up to y3. So just copy these. Maybe the individual I want to leave out, so I'm just going to copy those and paste it over here. Okay, so if I want to print only variable y1 and y2, I can leave out the others, and then the run at the end. And then to make it neat, I'm just going to keep a space over here. Okay, so always the run at the end of your proc steps. So semicolon, semicolon, semicolon. And I have to highlight everything from the bottom to the top, and then I click on this submit, then it will run the code for me. Okay, so again, the first step was just to check whether my data is imported correctly. And there's the bone data correctly imported. Nothing is wrong. I can do the rest of my analysis. So always check when you import the data whether it's correctly imported. Okay, the log will tell you if there was a mistake, but in this case there doesn't seem to be any mistake at all. And here's the fourth window that I mentioned. Okay, so let's go back to the editor again. So we know now our data is imported properly, and now we can continue with some other analysis. So the next one that I'm going to do is just to test for univariate normality of each of the variables in my bone data. So y1, y2, y3, y4, each of them is being tested as you see over here. Okay. Now, SAS is not case sensitive like R. You will see over here, since we've specified the names as small letter y's, if I run it over here as capital letter y's, SAS will not have a problem with that. So the proc univariate step can be used for multiple purposes. You will see in the output that I'm going to generate now. But what we want to do specifically is the normal test. And here's the title 2 to remind me what I am doing. Okay. Now, since we've already run the first one, this proc print over there, the data is now available in SAS for us. So we don't need to run this again, because if we run this again, it will add another set of output like this to the file. So we only want to run this part. Okay, so highlight only the parts that you want to run, and then if you click submit, and then it adds to the output. Now notice over here, since we have 4 variables, SAS have to look at each of them individually. But notice the output that SAS generates. The sample size, there's the mean, there's some other, the coefficient of variation, there's also t-tests that it's doing. That's how t-test where the mu is equal to 0. There's a test for normality. So notice over here there's the Shapiro-Wilk test and the p-value. And this is the p-value that we found in R when we did the Shapiro.test function. Okay, so the Kolmogorov-Smirnov, Kamer von Mises, Anderson Darling, those are all alternatives to the Shapiro-Wilk test. Okay, some more output extreme values. So SAS generates all these output which R didn't generate. And that's probably either you can see it as an advantage or disadvantage, but it's nice to have this output available just with a few lines of code. Okay, this is variable number 2, and we have it for all the other variables. Okay, variable number 4 as well. Okay, so this output, we can select them all and we can copy and paste them. There's different ways of exporting output like this to Word, for example, and then you can type out or interpret the results that you have over here. So that's the normality test. Okay, so we wanted those p-values over here to be bigger than 0.05 to accept normality. And all of these p-values are in agreement. They are all bigger than 0.05. So according to all these tests, the data for variable y4 and similar for the rest are normally distributed. Our editor window again, let's go to the mean vector. Notice over here we have a proc means step. So again, I make things easier by copying and pasting. This is the proc means step, and I'm doing this for the bound data. Now the reason why I specify the data always is because you can import another data set. So maybe at the bottom of this over here, I would like to put another data set. So if there's multiple data sets, then SAS won't know which one to use. So you want to specify the data that you want to analyze. So proc means, let's see what this does. Again, my second title is just telling me what to do, and this is a comment. And I can just add more comments if I want to. If I just want to work with variable y1 and y2, then I can leave out the others. Okay, and then run at the end, and always remember your semicolons. Okay, semicolons. If I make a mistake in SAS, the first mistake that I make or look for is usually, did I include a semicolon? Maybe at this time notice what's happening on the side over here. So on the side you will find all the results are piling up. Okay, so all the results that I've been doing, because like I said, you can do an analysis after analysis after analysis, and SAS keeps track of all those things. It will print the results in the result viewer, but you can also, if you quickly want to go back to the data, you can just click over there. If you quickly want to go to the summary statistics, you can click over there. Okay, and there's the means. So the output over here may be displayed differently than what we used to in R, but once you stick to one program environment, then you get used to the layout of the output. Okay. The next thing that we want to do is we want to do a t-test, and let's look at the proc t-test step. Okay, so there's the proc t-test, and then alpha that we're going to specify 0.05. What we're doing over here, you will notice I'm testing the hypothesis where the mu is equal to 60. Okay, so this is for a single group. The data that we have, if we look at the bound data, this is a single group. We're not comparing two groups or doing a paired comparison. So we only have a single group over here. So I'm testing whether the mean of this variable is equal to 60. The mean of this variable is equal to 60. The mean of this one is equal to 60. Okay, so think of this as individual t-tests for a single group. So again, run this for the bound data. At the moment, it's the only data set. So since it's the only data set, we didn't have to specify it. But later we will import another data set. Then we have to specify the data. Let's look at the output for this one. Okay, so there's quite some output being generated for this hypothesis test over here. So let's look at all the output. Okay, so there was the mean. Notice over there, these are my my titles. That's why I said specifying the titles is so important, because as you generate output, you at least need to identify what you are doing where. There's a t-test for y1, and we're testing whether it's equal to 60. This is the mean, so definitely much lower than 60. So typically we would, just based on this value, we would reject the null hypothesis. So this value over here tells me that the mean of y1 is less than or not equal to 60. There's just a distribution. You'll see there's some graphs that we do. That's the normal distribution. The blue one, it's the histogram. So maybe that could be of use. This is just a normal, also a QQ plot. So again, telling us that the first variable is normally distributed. There's a second variable. Second variable is normally distributed. There's the p-value and there's the mean. Okay, so based on this, there's a confidence interval over here. So 95% confidence interval for the mean. There's a 95% confidence interval for the standard deviation as well. So SAS gives you all these nice output that you may be interested in using. And the same for the other variables as well. Notice if you would change this to 50, how the p-values would change as well. Okay, this was just a number that I've chosen randomly to show you the output. And that's just for a single group. Okay, so these are all univariate still. Regression, correlation analysis. So again, if I copy these commands, again the help file, or if you can Google all these, there's a lot of examples in the help file, and we will look at the help file a little bit later. But here's the PROCOR. So the PROCOR do a correlation analysis for us, and again we want to do it for all the variables. So only this part we select, and then we run it, and there's my output. Okay, so not a lot of output like we saw earlier, but at least it contains the correlations that we are interested in. Now this is the Pearson correlation, but there's also other correlations that you can obtain, like the Spearman rank correlation. But this is the correlation that we normally would calculate. And this is a matrix. Notice over here, there's a 0.96 correlation between Y1 and Y2 and so on. And it's significantly different from 0. So there's significant correlation, significant. Everywhere you see there's a significant correlation. Okay, so that's the purpose of the p-value. And then next, this is where we perform a regression. So again, these examples are all to show you that whatever we did in R, we can generate similar output in SAS as well. So again, my second title is a progression step, give the data. And now I'm saying over here model. Notice over here the colors again, so I specify the model. So this is my Y, and these are just my X1, X2, and X3. And then these over here we can actually leave out. Okay, let's see if we leave them out. And that should be sufficient to generate the regression that we normally would want. Notice over here the output that's generated over here. So in this output, I'm going to call it new, there's a variable residual. I'm going to call residual. So we will look at this. I will print that. Let's print it. So let's say print, and then data equals new, because that's a data set that's now going to exist for us. And let's run it over there. So I'm first going to run this part, and it will do a normal regression for us. Again, the help file, you can look at the help file to see what else you can do. So this is the output for the regression. So there's the correlation still. There starts the regression. There's my dependent variable. There's my ANOVA, R square, adjusted R square. These are the coefficients. And then this one is significant. Those two are not significant. And these are just some diagnostic results. There's the predicted value and the residuals. It looks like it's constant. there's the QQ plot of the residuals, the predicted versus the actual. So it looks like it's doing quite well. Data looks like it's following or more or less close to the straight line. There's a few large observations or residuals that we want to investigate, but more or less good output. The R squared and the adjusted R squared showing us a good fit of the model. In this part over here, the new, let's see what it looks like. Okay, so there's what's happening. So the residuals was added, and it also shows you the data that we started with. Okay, so residuals was the variables or the column that was added. And this we can use for other purposes as well. Okay, so we can now refer to the new data and do something like what we had over here, univariate test. Okay, so maybe show that quickly. So I'm just going to copy these commands, and then over here I'm going to work with the new data, and then a univariate normal test of the residuals, and then the variable's name is reset. We call it reset. Why is it called reset? I called it reset over there. Okay, that's a name that I specify. You could have called it residuals. And if I run this part over here, notice this is now done on the residuals. And so the residuals, there's the p-value. Sorry, that's this p-value over here. So the p-value, it seems like the residuals are not normally distributed based on these p-values. Okay, we want these p-values to be bigger than 0.05. So there needs to be maybe a transformation on the data, or we have to do some other regression analysis if the residuals are not normally distributed. Okay, there's some more of there's actually the test that I just did. So that's basically sort of a quick introduction to some basic analysis that we would usually do on a multivariate data set. Now notice over here on the side there's this minus, and if I click on it, it will reduce the output in the window. Okay, so reduce it. I want now to start something new, so I'm just making my space a little bit neat. Okay, so let's do that. Okay, maybe something about the help file. If you click on the help file, then you would find that SAS, there's a lot of examples over here, so you can do a search. Let's say I want to do a regression in SAS, then you can search for regression, and it will show you some output that you can investigate. Okay, so let's say there's many regressions that you can perform. So I'm just going to first say progreg. Okay, progreg. See, there's a lot of regressions or associated procedures, but we want this one. There's the progreg, and these are, you can almost call them the arguments for the progreg step. Okay, so similar in R, where we have arguments, these are also arguments. Okay, and the examples will probably be more helpful if you scroll down. There should be, see, next page, there's the examples. So here's some ideas that you can follow up. There's the code, and you can follow up how to generate the output that you see over here. Okay, so they're helpful, pretty helpful in SAS. And you can do that for every other procedure that you want to use. So the next thing that I want to do is I want to look at the effluent data. Remember the effluent data where we have the paired comparison. So the first thing that I want to do again is I'm just going to paste the first part, and I'm using the data lines again. So the title and then the new data set, the effluent data. Remember, we still have the bound data at the top, but this is the effluent data. And so in Excel, again, to show you, we can copy, and now I'm just going to copy this maybe. Okay, and then SAS, I can paste, and then my semicolon. Okay, and what I can do is I can print my data set again to see if it imported correctly. So again, I like to run all these steps just to see that my data is imported correctly, because if it doesn't import correctly, then my other analyses would be incorrect. Okay, so again, I'll specify the names over there. There's 4. Remember to delete them over there. You don't want them over there. So it only starts at the first row and ends over there at the last observation. Semicolons, make sure of your semicolons again, semicolon. Your stars over here, commenting out the print for the effluent data, second title. And remember, we haven't run this yet, so we have to run the data. Okay, so that's where the data is being incorporated into SAS. And this part is where we actually print it to see if it prints correctly. And once you see this, then you are happy the data is correctly imported. So that's always the first thing, is make sure that the names of your data and your data itself is correctly imported, and then the rest of the analysis should be fairly straightforward. So we're dealing with paired comparisons, and so how do we do the analysis for that? Here's the commands using the POC-T test again. Testing equal to naught. Remember the effluent data, and notice over here the paired coming in. So going back to what we had over here for this t-test, we only specified variable 1 up to variable 4, and the null hypothesis was not equal to 0 but equal to a value. Over here we specify 0 because we're testing the differences. And notice over here x1 for the commercial lab and the state lab, x2 for commercial lab and the X lab, the state lab. And then running this part over here will give you some output that refer to the paired comparison test. Difference, notice there's a difference. We accept the null hypothesis, so there is no difference. Over here, accept null hypothesis, so there is no difference for the second variable. So similar to what we concluded in R, we see that the two labs produce the same results. There is no difference. Okay, so that's basic an introduction to R. What we see over here is another way of importing the data. So sometimes you import or have your data in an external directory, and then you want to call it from an external directory. And notice over here we have a backward slash, and in R we had a forward slash. Okay, so that's also a difference. But the idea with this little data step over here is to show you that if you have the data set, in this case it was a text, I converted the bound data to a text data set, I can import it into SAS using this statement as well. So at the moment we were copying and pasting the data for simplicity, but there are other ways of importing the data. Similar in R, there's many ways of importing your data. At the moment we're just using the most convenient and quickest way for illustrative purposes. But the more you learn R, the more you learn SAS, the more you will find these things over here useful in importing data. So to go back to what we have over here, I've shown you how to run the program. If you have a data set, and these are output over here, remember you want to maybe use it for another time. So if you click over here and if you say file, save as, you can actually go and save that output as a SAS file. Okay, so I'm just going to save it, and you will notice the output has an extension .sas. So let's call it computer lecture number 6, and then if that is the correct lecture, it's number 6, and so then we can save the output, and the next time that we use SAS, we can just go to that folder over here, find this SAS file, .sas file, click on it, and you will have all this information back again. And if you have all this information, you can just run it. If you click the submit button without highlighting everything, SAS will automatically run everything. Okay, so that's why it is important, if you want to run only part of it, to highlight it and then run only that section that you want to create. Okay, and then all the other outputs you can copy and paste and put it in Word for interpretation. So this is now saved, and again I can use this the next time, go to that file, open it and run it again in SAS to generate the same output. Again, these results over here are useful to navigate your way in the SAS windows. So we've spoken about the help file, finding mistakes in the log window. We've mentioned that. So if you make a mistake, maybe just for illustrative purposes, so what I'm going to do is I'm just going to leave out a comma over there, a semicolon. So if I run this, you will notice this will probably now continue running and running and running. And the question is, if you do something like this and you want to stop this program, then what you can do is click on the break over here. So this thing is going to run forever unless you break it with this thing. So breaking it will just stop the statement. Okay, so then we can put back our semicolon. So let's say over here I leave out one of those, and then I am going to run this. Maybe we can use an easier example or easier piece of code. So let's put that back. But let's say over here I leave out this one, and this one will run it quicker. Okay, so again, you notice it's running and running, so we just need to break it. Let's put back the semicolon. Okay, but in any case, if you find there's a red something written in red over here in the log file, that's usually where your mistake, you will find your mistake. So those basically are all the things for now to look at. And in SAS, if you say select all or clear all, you can do that. And but in the end, like I said, these are all the files or the commands that you want to save. So click here, and I'm just going to say save again because I've already saved it over there. So that's a short introduction to SAS. We will do some more work with SAS in a later computer lesson. Thank you, and enjoy working in SAS.